Hello student, I am Ms. Minosh Shamli, Assistant Professor in the Department of Artificial Intelligence and Machine Learning at Rohini College of Engineering and Technology. I am handling subject 24A 302 Artificial Intelligence. Unit 3 Introduction to Inference in First Order FOPL. We are going to study about the inference. The inference is the process of deriving new fact or conclusion from the fact that are already known by using logical rules. In artificial intelligence, simply storing knowledge is not enough. An artificial intelligence should also be able to think and make decisions based on the available knowledge. This process of drawing conclusion is called inference. In first order predicate logic, knowledge is represented using predicate, object and relationship. Inference helps us use this knowledge to answer question or solve problem. There are two major techniques: first order, forward chaining, backward chaining. Mm, the forward chaining is also known as data-driven approach. The backward chaining is also known as goal-driven approach. Forward chaining uh, starts with the known fact available in the knowledge base. The inference engine check all the rules and every applies the rules whose conditions are satisfied. A new fact are generated, they are added to the knowledge base. This process continues until the desired goal is reached or no additional facts can be derived. Since it starts with the available data and moves towards the conclusion, it is called data-driven reasoning. Forward chaining works well in the situations where all the facts are already available. Let us understand this with an example. Suppose we have the rule: if a person is human, then that person is mortal. Now the known fact is the Socrates is a human. Since the condition is satisfied, the system applies the rules and concludes that Socrates is mortal. Here the conclusion is automatically derived from the available fact. This is how forward chaining works. Next, backward chaining. Backward chaining works in the opposite direction. Instead of starting with known fact, it starts with a goal or hypothesis. The system that then searches for rules that can prove this goal. Next, it checks whether the condition of this rule are satisfied. If necessary, it creates smaller sub-goals and continues working backward until it's reached known fact. Because it starts with the goal and searches backward, it is called goal-driven reasoning. Let us take a same example. Suppose our goal is to prove that Socrates is mortal. The system looks for the rule that concludes mortal. It finds the rule if human then mortal. Now it asks whether Socrates is human. Since this fact is already known, the goal is successfully proved. Therefore, backward chaining becomes the goal and searches backward for supporting evidence. Next, forward chaining processing steps. The first step is start with known fact. The inference engine begin with all the facts stored in the knowledge base. The second step is apply rules. It search for rules whose condition match the available fact. The third step is inference infer new fact. Whenever a rule is satisfied, a new fact is generated and added to the knowledge base. The fourth step is repeated. The system continues applying rules until no more rules can be applied or the desired goal is achieved. Let us understand this with a medical diagnosis example. Suppose the known fact is that patient has a fever. Another rule says if a patient has both fever and rashes, mm, the patient have a measles. The system later receives additional fact that the patient also has rashes. It combines both facts and concludes the patient may have measles. This illustrates how forward chaining other building knowledge from existing fact. Next, backward chaining process step. The first step is goal with the start with the goal. The inference engine begin with the conclusion it want to prove. The second step is identifying rule. It search for rule that can prove the required goal. The first step is check condition. The system verifies whether all the conditions of the selected rules are true. If some conditions are not directly available, they become a new sub-goal. The fourth step is recursive process. The system continuously is searching backward until it reaches fact that already exist in the knowledge base or until it determines the goal cannot be proven. Suppose the goal is to determine why the condition computer is down. The system find a rule starting that if the router is malfunctioning, then the network will be down. Um, Next, uh, if it is the router manufacturing the system, now check the router state. It confirm that the router has failed, then the original goal is successfully proved. This is the working principle of backward. Next, thank you.